Okay, so question 4. Is CH3Cl polar or nonpolar? Okay, so it helps if we find out the Lewis structure of our molecule first, since this will help us answer whether or not it's polar or nonpolar. So to find its Lewis structure, first let's calculate the total number of valence electrons. In the case of carbon, there are 4. In the case of hydrogen, there's 1, and we multiply this by 3, since there are 3 hydrogen atoms. And in the case of chlorine, chlorine has 7 valence electrons. So if we add this up, we get 14 valence electrons as our final electron count. And let's draw carbon as our central atom. And then I'll just draw single bonds all around. And let's see how many electrons I've drawn so far. So each bond contains 2 bonding electrons. And we have 4 bonds, so that's 8. So I just need 6 more electrons to fill up my 14 electron count. And the remaining 6 go on my chlorine atom as lone pairs. Okay, so now I have a valid Lewis structure for our molecule. When determining whether or not a molecule is polar or nonpolar, first we want to see if any of the bonds are polar within the molecule. So step 1 is to check if any bonds are polar. And typically, when bonds are polar, they have an electronegativity difference that is greater than 0.4, or I'll just say greater than or equal to 0.5, but typically less than 1.69. Okay, so we need to see if any of the bonds are polar. So first, let's look at the electronegativity difference between a carbon and a hydrogen. So we just look up the electronegativity values, and you can see that was kind of small, but basically carbon has an electronegativity value of 2.5, and hydrogen has an electronegativity value of 2.1. So 2.5 minus 2.1 is equal to 0.4. So the carbon-hydrogen bond is considered nonpolar. But if we looked at the electronegativity difference of carbon and chlorine, chlorine has a value of 3.0 and carbon's is 2.5. So the difference is 0.5. So I can say that the carbon-chlorine bond is polar. And the second step to check to see if a molecule is polar or nonpolar is to just kind of look at the Lewis structure to see if it is symmetrical in any way. And we can also show at this point, because the carbon and chlorine bond is polar, and a chlorine is more electronegative than the carbon, then we can show that there is a dipole moment pointing towards the chlorine atom. So step 3 is to look at the net dipole moment. So since chlorine is much more electronegative, then the hydrogens don't cancel out this dipole moment that chlorine is forming. So we have a net dipole moment moving towards the right of our molecule, causing a partially negative side and a partially positive side. So because of this non-zero dipole moment, we know that our molecule is polar. So I can say that CH3Cl is a polar molecule. Okay, so now let's see what the junior tutor said. Polarity refers to the charge separation, which causes the presence of a dipole moment. Additionally, polarity can be viewed from the perspective of a bond or the entire molecule itself. A bond can be polar because the electrons are unequally shared between the bonded atoms due to their electronegativity difference. However, although a molecule has polar bonds, this does not imply that the entire molecule is polar. If the molecule's symmetry results in the cancellation of the dipole moments, overall the molecule becomes nonpolar. Let us first check if it contains polar bonds. So each carbon-hydrogen bond is nonpolar because carbon and hydrogen have a small electronegativity difference. However, the carbon-chlorine bond is polar because the electronegativity difference between the bonded atoms is moderately large. Since there is only one significant dipole moment, regardless of the shape of the molecule, we are certain that nothing will cancel out this dipole moment, and therefore CH3Cl is a polar molecule. Okay, so this solution is correct.